Hey everyone, I hope you're doing well today. In this video, let's take a look at linear equations and hopefully I can help simplify down them a little bit for you. If at any point you want to pause the video to think a little bit or to try a problem on your own, feel free to do so. Otherwise, let's get right into it together. For this first example, let's try out this equation of negative 2x plus y is equal to negative 3. For this practice problem, we're going to go ahead and see if we can graph it, but just a little review and reminder, this is technically a linear equation that's in standard form, and we're going to see if we can rewrite it into Y-intercept or slope-intercept form before we go ahead and do so. So to turn this into a form that's a little bit easier to graph, which is slope-intercept form, let's isolate this y. So I'm going to go ahead and add 2x to both sides of the equation. So if we do that, we're going to have y is equal to 2x minus 3. So while this equation looks different, keep in mind that it's the same equation just written in a different form called slope-intercept form. When equations are written in slope-intercept form with the y isolated alone, it's a little bit easier to come up with some points that we can use to graph the equation. So let's go ahead and make a xy table, and let's try and create some points that will fit on this line. So I'm going to go ahead and make it big enough so that we have, let's say, 5 points. That's usually a good number to have, 1, 2, 3, 4, and 5. That looks good right about there. And you just are going to go ahead and make up 5 random x values, but typically people will choose like negative 2, negative 1, 0, 1, and 2. So again, go ahead and choose any x's you want, but I like choosing some numbers that are a little negative, a little positive, all centered around 0. Okay, so what you're going to do here is you're going to take our equation and you're just going to substitute these in, right? So we're going to do it a few times. So we'll have y is equal to 2 times negative 2. That's the first x value, and then minus 3. So 2 times negative 2 is negative 4. Negative 4 minus 3, that's going to equal negative 7. So when x is negative 2, we know y is equal to negative 7. Then we're going to go ahead and do this again. We're going to say, okay, y is equal to 2 times negative 1, and then minus 3. So 2 times negative 1 is going to be negative 2 minus 3. That's going to be negative 5. So when x is negative 1, we know that y is going to be negative 5. Following that, we know x is 0 now, so we have y is equal to 2 times 0 minus 3. 2 times 0 is going to be 0 minus 3. That'll be negative 3. We can go ahead and put that in when x is 0, y is negative 3. And we're going to keep on going and doing this a few more times. So y is equal to 2 times, now x is 1, so it's going to be 1, then minus 3. 2 times 1 is 2, minus 3, that's going to be negative 1. Go ahead and put negative 1 there. And then doing one final one, let's say we have y is equal to 2 times, let's say x is 2, and we're going to take away 3. 2 times 2 is 4, and then 4 minus 3 is going to equal 1. So when x is positive 2, y will equal positive 1. So now that we have a table with 5 different ordered pairs, we can now graph this linear equation on a coordinate plane. For this first point of negative 2 comma negative 7, that's going to go ahead and go 2 to the left from the origin, and then 7 units down. So that's going to be over down in quadrant 3. That's going to be that first point. For the next point, we have negative 1 comma negative 5. So that's going to be also in quadrant 3. That's 1 to the left from the origin. And then I think that's going to be 5 units down. So that's going to be located right about here. Then for third one, we have 0 comma negative 3. That's going to be located right on the y-axis. But on the negative part of the y-axis, right about here, looks just about right. Then our next point is going to be 1 comma negative 1. So that's going to be over in quadrant 4, right? So to the right of the origin, then down 1. It's going to be located right there. Okay. And then finally, we have one more point of 2 comma 1. So let's go 2 to the right and then up 1. So right about there seems good. Now that we have a few different points here, I'm going to go ahead and show you where the line would be. So right about there looks good. And this would be the graph of our linear equation. So there's our first example where we took an equation written in standard form and we rewrote it so that it was in slope-intercept form. Then we made a table, made up some x values, so we plugged those in to get some y values so that we had some ordered pairs. And then plotting those 5 different points, we were able to create a linear linear equation, but put it onto a coordinate plane, so we had a graph there. Let's try a different type of problem now. Let's say we have 3x minus 2y is equal to 12. For this problem, let's see if we can find out the x-intercept and the y-intercept for this one. So let's try to remember what those are. Let's start with the X-Intercept. So the X-Intercept for an equation is going to be where the graph crosses the X-axis, and it's always going to be when the Y value is 0. So we're going to go ahead and take this equation. We're going to take 3x. Remember, the X-Intercept is when Y is 0, so we're going to change Y to 0. So we'll write 2 times 0 and set that equal to 12. Okay. Then we'll go ahead and solve this. We'll find out what the X-Intercept is actually going to be. So 2 times 0 is going to be 0, and we'll set that equal to 12. We can not write that minus 0 and just drop it, so we can write 3x is equal to 12. Then we can go ahead and divide both sides by 3 here. Dividing both sides by 3, we find out that x is going to equal 4. But when was x equal to 4? X is equal to 4 when y was equal to 0. So for X-Intercept, we can say that's going to be 4, 0. Okay, so when y was 0, x was 4. Now a little different, let's go for the Y-Intercept now. So for the Y-Intercept, that's where x's value is going to be 0. So anytime a graph crosses the y-axis, the x value is 0. So we're going to say 3 times, and let's substitute that in, it's going to be 0 for the x this time, minus 2y, and that's equal to 12. So 3 times 0, what's that? That's just going to be 0. So we'll have 0 minus 2y is equal to 12. And we can drop that 0, so we can just write negative 2y is equal to 12. And then if we go ahead and just divide both sides by negative 2 to get y by itself, or to get its coefficient to be 1, then we can go ahead and say that y would equal negative 6. So when was y equal to negative 6? Well, we plugged in 0 for x, so we can go ahead and say that when x was 0, then y was equal to negative 6. So there's our Y-Intercept here. And just for good measure, let's go ahead and take a look at this on a graph. So looking here on a coordinate plane, we can plot our X-Intercept we found at 4, 0 right over here along the x-axis. And then we can go ahead and plot our Y-Intercept of 0, negative 6 right along the y-axis right about here. Going ahead and drawing a line through these 2 points, we can go ahead and graph this and say this would be the graph for this linear equation, and we see those 2 intercepts. Right over here is where the X-Intercept is going to be located, so notice how its y value is 0 at that point. And then down here, this is going to be the Y-Intercept, and notice how at the Y-Intercept, the x value, or the x-coordinate, is equal to 0. So long story short, whenever you're looking for an X-Intercept, just make sure to plug in 0 for y and then solve for x. That'll give you your X-Intercept. And when you're looking for the Y-Intercept, make x equal to 0 and solve for y, and that will give you your Y-Intercept. Now let's switch gears a little bit and talk about slope. So I'm going to give you 2 points to start here. So the first point is going to be negative 4, positive 2. And the second point I'm going to give you is going to be positive 2, positive 6. So given these 2 points, let's see if we can find the slope of the linear equation that would go through both of them. While some people like to go with the formula first, I like to go with the picture first because this makes a little bit more sense to me. So let me go ahead and show you this on a graph first. For this first point of negative 4, 2, that's going to be 4 units to the left of the origin and then 2 units up. So that's going to be in quadrant 2 right over here. And for the second point, we have 2, 6. So I'm going to go ahead and plot that over in quadrant 1. So that's 2 units to the right of the origin, and then it's going to be 6 units above the origin. So that's going to be right over here. At this point, it's really important to remember what slope actually is. I know we use this letter m to represent it, but really it's just a ratio of the rise to the run, or the vertical change to horizontal change. So the slope, or m, is just going to be equal to the ratio of the vertical change to the horizontal change between these 2 points. Going from the green dot to the purple dot, we have a vertical change of 1 unit, 2 units, 3 units, and then 4 units. So since we're moving up, that's going to be positive 4. And for the horizontal change, we're going to be moving to the right 1 unit, 2 units, 3 units, 4 units, 5 units, and then 6. So moving to the right is a positive direction, so it's going to be positive 6. So slope is the ratio of the vertical change to horizontal, so the vertical was positive 4 or up 4, and the horizontal was to the right 6 or positive 6. So we can go ahead and say, well, a positive divided by a positive is still a positive, and 4 over 6 reduces down or simplifies down into 2/3 or 2 to 3. That's the slope, or the ratio of rise to run, or the vertical to horizontal change. And if you're wondering if we're allowed to go from the purple to the green dot, we absolutely can. It's also going to be the ratio of vertical change to horizontal change. So going from purple to green, we're going to go down 1 unit, down 2, then 3, down 4. So that's actually 4 units down, or negative 4, okay? And then for the horizontal change, we'll go 1 to the left, 2, 3, 4, 5, and 6. Since we're moving to the left here, that's going to be negative 6. So let's see how this is related. So we can, if we go from the purple to the green instead, it's just going to be down 4 and to the left 6. So a negative over negative is still going to be a positive. So we still end up with a slope of 2 to 3. So now we visually understand what the slope is by looking at the coordinate plane. Let's take a look at it when we just have the ordered pairs or the numbers. So for this first one, let's find the vertical change. So for this first one, let's call this y1. And then for the second point, we're going to call this y2. So these are both our vertical numbers. We're telling us how far up and down we are. So when we find slope, we generally see this equation. We're going to say slope is equal to, and people will say, okay, that's going to be y2 minus the y1. So that's going to be the vertical change. And then we're going to see what we're going to do with that. So afterwards, and for our horizontal numbers, we can go ahead and say this one is going to be x1, and we can go ahead and say this 2 over here is going to be x2. So if we're going to say y2 minus y1 on top, we're going to go ahead and say this is going to be x2 minus the x1 on the bottom. And if you were to switch this up a little bit and you didn't want to go this way, it's totally fine if you go ahead and say something like this, where you say y1 minus the y2. That's perfectly cool. Okay, and then on the bottom, as long as you go 1 to 2 on top, you also have to go 1 to 2 on bottom. So just say it's going to be x1 minus the x2 on bottom. So either one's okay. Hopefully that makes sense based on the drawing I made to the right, because I did both of these. It doesn't matter which point you start with, purple to green or green to purple, you can get the slope just fine. So let's go ahead and plug some stuff in here. So y2, that's going to be 6, and then minus y1, that's going to be 2. And that's going to be all over, let's see, x2, I think we said was 2 earlier. And then x1 is going to be negative 4. So it's going to be 2 minus, and we'll put a negative 4. Okay, so if we go ahead and simplify this a bit, simpleefy, 6 minus 2 on top is going to be 4. And then on the bottom, 2 minus minus 4, keep change flip, or keep change. That's going to be 2 plus 4, which is 6. And then 4 over 6, divide them by their GCF of 2, get to a slope here of 2/3. And that matches with everything we said earlier. So given 2 points, all you really have to do is find the distance between their y coordinates and the distance between their x coordinates and set up a ratio and simplify. So let's try another similar one here just for some practice. We have 5, 2, and let's do another point where it's going to be 4, negative 1, and let's find the slope between these 2 points. So just to label things to get organized here, let's call this one x1 and y1, and we'll call the second point here x2 and y2. And that way we can find the vertical distance and horizontal distance. So slope here, remember, is going to be the rise over run, or the vertical distance. So that has to be the vertical distance between these y coordinates, so y2 minus y1. And then that's going to be over the horizontal distance between them, and that's going to be x2 minus the x1. So go ahead and write it just like this. And then we can make some substitutions here, right? So y2, it looks like, is going to be negative 1. So I'll write negative 1 minus. And then y1 is going to be the value of 2. So go ahead and write minus 2. And that's going to be over x2, which is going to be 4. So I'll go ahead and write a 4. And then minus x1, which I think is going to be 5. Let's go ahead and put that 5 here. Okay, so in a numerator, negative 1 minus 2 is the same thing as negative 1 plus a negative 2 if you do keep change flip. So negative 1 plus negative 2 is going to be negative 3. And then on the bottom, we have 4 minus 5. If we know 5 minus 4 is 1, then 4 minus 5 is going to equal negative 1. So a negative over negative is a positive, so we're just going to have a slope here of 3. And just to confirm this, I'm going to put this on a graph just to show you that this does make sense. So our first point is going to be 5, 2, so that's 5 to the right of the origin and 2 units up. That's going to be over in quadrant 1. And then for our second point, we have 4, negative 1, so that's going to be located in quadrant 4. So that's 4 units to the right of the origin and then 1 unit down. So this is where that second point would be. The linear equation will look something just like this. This is the line that would go through those 2 points. And our vertical change here is going to be 1 unit, 2 units, and 3 units. So that's positive 3 in the vertical direction. And it's going 1 to the right, which is going to be positive 1. So the ratio of positive 3 to positive 1 is just equal to 3. So that works out. Here's one more practice problem for good measure. Imagine we have a point that's going to be negative 3 comma y plus 1. So there's kind of an expression there for that y value. And the second point here is going to be 0 comma 4. So given these 2 points, I'm also going to tell you what the slope is here. So I'm going to say the slope is equal to positive 6. And the goal here is to find out what the value of y is. So a little bit of a different type of problem. If you have to try it on your own, go ahead and pause the video, and then I'll go over it in just a moment. So we'll call this negative 3 our x1, and we'll call this entire thing of y plus 1, we'll call that our y1. And then for our second point, we'll call the 0 here our x2. And then for the second point of 4, or the y-coordinate, we'll call that our y2. So what's our original equation again? Its slope is equal to, and we'll go ahead and write that in, it's y2 minus that y1. So go ahead and write it just like that. And on the bottom, it's going to be our x2 minus the x1, just like this. So remember, we do actually know the slope here, so we're going to go ahead and put in our 6 to the left. And then for y2, we know that's equal to 4, so we're going to plug that right in and take away what's y1. Well, it turns out y1 was actually y plus 1, so make sure you put in parentheses to group it, and put that whole thing, that's our y1 value, and that's going to be all on top of x2, which x2 I think is 0. So it's going to be 0 minus x1, which is a negative 3. So go ahead and write that in parentheses as well. Just keeps things a little bit more organized. Okay. Going ahead a little bit here, we can say 6 is equal to, so we'll go ahead and distribute this minus sign right over to this y and over to this 1. So we can go ahead and say this is going to be 4 minus y minus 1 if we distribute that properly, all over what's 0 minus a negative 3, so keep change flip, or keep change change, and so that's going to end up being 0 plus 3, or just 3. Okay. On the numerator, on the right side, we can simplify that a bit. So 4 minus 1 is going to be 3. So 3 minus y all over 3. So I'm running out a little bit of space here, so let's continue this over here. I'm just going to copy this down, say 6 is equal to 3 minus y all over 3. And again, we're solving for y here. So I think in order to solve for y, let's go ahead and multiply both sides here by 3. So if you multiply by 3 on the right and 3 on the left, then 3 times 6 is going to be 18. And then on the right side, those 3's are going to cross cancel, so we're just going to have 3 minus y. And then we can go ahead and subtract 3 from both sides of the equation here. So subtracting 3 on both sides, 18 minus 3 is going to be 15. So we'll have 15 is equal to negative y. And if we divide the right side by negative 1, divide the left side by negative 1, we'll end up saying that y is equal to negative 15. Now, if you want to take this and check it, feel free to do so. We can go ahead and take this negative 15 and plug it in right there. So plugging that negative 15 into the original, we'd have negative 3 as the x value, then negative 15 plus 1 would be negative 14. That would be that first point. And the second point would be 0 comma 4. So those would be the 2 original points now that we know what the value of that y variable was. So if we go ahead and say that's x1 and y1, and over here we have x2 and y2, we can go ahead and see, okay, slope here is going to be y2 minus y1, so 4 minus 14. So I'm just skipping the colors here and just going straight into it, just to hopefully help you see this. And then x2 minus x1, so 0 minus 3. And so 4 plus 14 is what we're going to have on top, that's 18. And on the bottom, 0 plus 3 is going to be 6. So 18 divided by 18 divided by 6 rather, does equal 3. So once again, this does work out. So just a few different types of practice problems, but hopefully this helps with just getting some practice with linear equations down. So hopefully you found this helpful. And as always, keep up the great work, and I'll see you in the next one.